Okay, so review. Let's do some limits first. I'll do a few. So limit as x approaches 5 of 50 minus 2x2 over 2x2 minus 9x minus 5. Here's one. Second, x approaches negative infinity, square root 4x6 minus 9x over x cubed. Okay, start with these two. A third one here. Limit 3 from the right. Absolute value of 6 minus 2x over. Okay, so start with these three. First thing we do as usual, we replace 5 inside. So if I replace 5, I get 50 minus 50 is 0, and on the bottom I get 50 minus 50 is 0. Okay, so two options, either we factor or we use L'Hopital's rule, whatever you prefer. I think let's do L'Hopital's rule, it's easy. Limit x approaches 5, derivative of the top is negative 4x, derivative of the bottom is 4x minus 9. Plug in 5, I get negative 20 over 11. Is that what you got? Yeah? So minus 20 over 11. This one here, plug in infinity, of course you get infinity over infinity. Forget the signs. And so when there's a square root, I'm not a big fan of using L'Hopital's rule because the square root just doesn't disappear. So we're just going to factor out the big exponent on the top. Okay, so limit, like we did at the beginning of the course, square root, so x6 times 4 minus 9 over x5, if you remember. And at the bottom we have x cubed. Okay, square root of x6 is x cubed. So limit x approaches negative infinity of absolute value of x cubed. Don't forget the absolute value, that's important. 4 minus 9 over x5, and on the bottom we have x cubed. And then since it's a negative infinity, then when I take out the absolute value, it becomes minus. So this is the trap. A lot of students forget this minus. Okay, cross out the x cubes. And then at infinity, this becomes 0. So you have negative 2.
Yeah, sure.
Yeah.
If it was x squared, will it be plus?
Yeah, very good point. Yeah, you're right.
Okay.
All right, here. There's an absolute value. So limit x approaches 3 from the right. I'm going to pull out a 2 outside, absolute value of 3 minus x over square root of x minus 3. If you plug in 3 plus inside, so the inside is negative. And so if I take out the absolute value, you have to put a minus in front. 2 times, so negative 3 minus x over the square root of x minus 3. put brackets for nothing. And then here, limit x approaches 3 plus minus, I could change the signs, 2 times x minus 3 over root x minus 3. And that, if you simplify, you'll get 2 root of x minus 3. And so you get 0.
So why did you put a minus?
Because, this minus here?
Yeah.
Because 3 plus, that means that x is bigger than 3. That means 3 minus x, this will be a negative number, guaranteed. You understand?
Yeah.
And if this is a negative number, then the absolute value has to be positive. So to replace the absolute value, I put a minus, that minus and negative, now this is positive. Okay?
Yeah.
Okay, let's continue. Let's do as many problems as we can, okay? The more practice, the better. So this was number 3, so let's go number 4. Limit x approaches 0, 6x over sine 3x times cos 4x. Okay, so here's 1. Okay, so this is an easy one. So again, if you plug in 0, you get 0 over 0. So don't ever forget to plug in at the beginning, because you could end up wasting 10 minutes factoring and breaking your head. Well, you just plug it in and it works. I've done it before. Okay, so equals to, I'm going to pull out a 2 outside. Limit x approaches 0. Why did I pull out a 2? Because now I have 3x over sine 3x times 1 over cos 4x. And as you all know, this limit here is 1. And this, of course, is cos of 0 is 1. And so the answer is 2. Okay, straightforward. Let's do one more limit. Limit as x approaches infinity, e power x minus e power 2x. So first thing we do, plug in infinity. E power infinity is infinity. E power infinity is infinity. So we have infinity minus infinity, and that's undetermined. I have no idea what that is. Okay, but what I could do, I could extract an e power x times 1 minus e power x. And that will give me what? If you plug in infinity here, you get infinity times 1 minus infinity, so negative infinity. And so infinity times minus infinity gives you minus infinity. Okay, so that was much easier than expected.
Sure. I have a question. When you plugged in infinity, it gave you negative infinity. So why do we still need to solve it again? Because we still got an undefined form.
Why? I'm not sure I understood. Why is it here, you mean?
Yeah,
What about, what do you expect here?
we got negative infinity, right?
It's plus infinity minus infinity. I don't know what that is.
Okay.
That's undetermined. I can't say it's infinity. I can say it's minus infinity. I can say it's a number. I can't say anything here.
Okay.
Until I write it this way. Here, right now, I recognize infinity times infinity is infinity, and plus times minus is minus.
Yeah.
Okay, good. Next, let's do a continuity one. Okay, let's move on. Continuity, then we'll go to derivatives. So that was number 5, so let's go number 6. So let's say f of x is x2 minus 4 over x2 minus x minus 6 if x is less than or equal to minus 1. Then 1/4 x plus 1 if it's between -1 and 5, not including, and 1 over x2 minus 10x minus 24 if x is greater or equal to 5. So this is my function. Okay, the question is find all numbers at which f is not continuous. Okay, and then of course classify the type of discontinuity. Yes, when I say classify the type of discontinuity, means is it a removable, a jump, or an infinite discontinuity? Okay, so let's see what are the possible problems. So I see, I'm going to factor everything. I'm going to rewrite in factored form. So the top function will be x minus 2, x plus 2. And on the bottom, I have x minus 3, x plus 2. That's for x less than or equal to minus 1. Here, there's nothing to do. 1/4 x plus 1 minus 1x, 5. And here I could factor. I get 1 over x minus 6, no, x minus 12 times x plus 2. This is if x is greater or equal than 5. Okay, so what are my candidates? Okay, so possible, potential problem, potential issue where? So x is equal to -2, x equals to 3, right? But 3, I don't consider because this is only when x is less than -1. So at x equals -2, I have to investigate. What else? Where else do I need to investigate? X equals what? You guys are sleeping.
Wait, can you repeat the question?
Yeah, what are the values of x where the function might be discontinuous? So we set at -2 because we have a denominator of 0 here. Okay, another place would be at -1, right? -1, because these two functions connect. They have to make sure they connect correctly.
Is 12 another answer?
Yeah, very good. 5 also, because at 5 it connects. And at 12, like you said, very good. Okay, so I have to check for each of these. I have to check, test for continuity.
Wait, isn't 3 as well?
Okay, good. 3 here.
Yeah.
Yeah, the thing is that this function here is in effect only when x is less than -1. So 3, there's no, x is never 3 here.
Okay.
Okay, when x is 3, it falls here. And there's no problem at 3. All good? Okay, so let's see. Let's start with x equals -2. So I'm going to do the limit as x approaches -2 of f of x. That is the limit as x approaches -2 of this function here. X minus 2, x plus 2, x minus 3, and x plus 2. I'm going to cross out. If you plug in -2 here, you get -4 over -5. So 4 over 5. Okay, so the limit exists. But f of -2 doesn't work. So what can you say about this function at -2? What type of discontinuity do we have? No? Okay, so there's a removable discontinuity. At x equals -2. Okay, so maybe I'll try something like this here at -1, -2, and 4/5 somewhere here. The function has an open dot. That's what's going on at -2. Questions? Okay, let's keep going now and see at -1. So here it connects, so I have to do limit approaches -1 from the left, limit x approaches -1 from the right of f of x. So -1 of f of x. So to the left of f of x, of what? To the left of -1, I have this function here, which I already factored as x minus 2, x plus 2 over x minus 3, x plus 2. And at -1 from the right, I have 1/4 x plus 1. Plug in -1 here. I get -3 over -4, so I get 3/4. And if I plug in -1 here, I have -1/4 plus 1 is also 3/4. So limit exists. Okay, the only thing to do now is to evaluate f of -1. And if you plug in -1 into this function, because that's when it's equal to -1, you will get also 3/4. F is continuous at x equals -1. You guys okay? Then we said x equals 5. Okay, so it's a long question, but it's really not difficult. So limit x approaches 5 from the left, limit x approaches 5 from the right of f of x. So to the left of 5, we have 1/4 x plus 1. And to the right of 5, we have 1 over x2 minus 10x minus 24. Let me see if I remember correctly. I think so. Yes. So what do I get? If I plug in 5 here, I get 5 over 4 plus 1 is 9 over 4. And if you plug in 5 in here, you get 25 minus 24 is 1 minus 50 is minus 49. So definitely not the same. Limit x approaches 5 f of x does not exist because left and right is not the same. And so f has what type of discontinuity here?
Is a jump
The jump.
discontinuity?
Very good. At x equals 5. Okay, and last one, x equals 12. Limit x approaches 12 of f of x is equal to the limit as x approaches 12 of 1 over, so x minus 12 times x plus 2. And so you will get 1 over 0. Okay, so we've done this a lot. We have an infinite discontinuity for sure. There's an asymptote here. And we could go a bit further and see if it goes to plus infinity or minus infinity. Let's do it. Limit x approaches 12 from the left. Limit x approaches 12 from the right. Okay, to the left of 12. So this is always positive, that's not a problem. To the left of 12, so this is going to be a negative number. And so I'm going to get like 1 over 0 minus, so I'm going to get negative infinity. And from the right side, positive, so 1 over 0 plus will be positive infinity. And as you see, limit x approaches 12 of f of x does not exist. And there is, f has an infinite discontinuity at x equals 12. So from the left, minus infinity, and from the right, plus infinity. Okay, so let's do this last one for today. So y prime, so 5 power cotangent stays 5 power cotangent times the derivative of cotangent. So I'm going to do the steps. Okay, plus the derivative of secant is secant times tangent times the derivative of the inside. All right, don't forget the chain rule. And time minus what? 2 times pi plus 1 times e to the pi, no, minus 1 from the exponent.
I think at the end it's 0, but
Oh, yeah, you're right. Yeah, it's 0. Okay, good.
okay, but like at the beginning, don't we have to do like 5 cot x times the derivative of cot x times ln 5?
Very good. Yeah, times ln of 5, right?
Yeah.
Very good. Okay, good stuff. So 5 power of cotangent x, derivative of cotangent is negative cosecant squared times ln 5 plus secant of 4x2 tangent 4x2 times this is 8x. And that's my answer.